Ladies and gentlemen, the moment you have been waiting for. We are going to talk about our first AI model, rule-based systems or expert systems. Emerging in the 1970s, back when disco was hot and bell-bottoms were in, rule-based systems were developed to mimic decision-making processes of humans relying on a set of predefined rules. MYCIN was an example of an early rule-based system with around 500 rules that aimed to diagnose bacterial and blood infections and suggest antibiotic treatments. While this 1972 system performed equal to human specialists and better than general practitioners, it never was used in practice. It was considered impractical to use since it was a standalone system that would have required extensive manual input from physicians, which would have been very time-consuming. In the years since then, we have used rule-based systems in virtually every industry, including but not limited to medical diagnosis, compliance checking, and customer service chatbots. Basically, if you ever yelled "representative" into a phone, you'll come across a rule-based system, among other AI models. Before we go into how rule-based systems work, I'd like you to keep the following big idea in mind. Rule-based systems are interpretable. Interpretable essentially means that we can easily understand why the AI model took certain decisions. That is, we easily understand cause and effect. It's the difference between Sherlock Holmes telling you how he came to the conclusion that so-and-so was the bad guy, as opposed to just telling you who the bad guy is. As we learn more about other models in future modules, we'll learn how more complex models are often not as interpretable. Okay. So let's get started. There's a few definitions we need to know right off the bat. Assertions. Assertions are statements known to be true. These statements are either provided to us or derived. For example, A0, Ella is a princess. Rules are if-then statements from which we can arrive to other assertions. For example, if X is a princess, then X lives in a castle. X can represent any person in the list of given assertions. If the if portion, which we call the antecedent, matches one of the assertions, then the then portion, which we call the consequent, is true and will be listed as a new assertion. For example, it is given to us that Ella is a princess. Using our rule, we can substitute X with Ella. So if Ella is a princess, which yes she is, according to A0, then Ella lives in a castle. Thus we derive A1. Ella lives in a castle. Now, our rules can get a bit more complicated. For example, we may have a rule that says if X is a princess and X likes frogs, then X will kiss a frog. And maybe another rule that says if X is a princess or X likes frogs, then X will marry a prince. So let's talk about the logical operators and or. If two statements are connected by and in the antecedent, both statements must hold for the consequent to be true. If two statements are connected by or in the antecedent, one of the statements must hold for the consequent to be true. So let's revisit our rules. We're going to again substitute X with Ella. We know from A0 that Ella is a princess. Since the antecedent contains an and, both statements must hold true. So we must check the second statement. Does Ella like frogs? None of our existing assertions mention if Ella likes frogs, so that statement is false and we cannot derive any assertions. However, if we take a look at the next rule, we know that Ella is a princess. Since the antecedent contains an or, we do not need to check if the statement is true. We know that the consequent is true, that is, Ella will marry a prince. So we derived our A2. Ella will marry a prince. That's great and all. Too bad there were no rules if X is a cat, then X will marry a prince. I feel like I was made for royalty, you know? Anyway, in the next couple of videos, we're going to use everything we have learned so far for forward chaining and backward chaining, two ways in which we can use rule-based systems to solve complex problems logically. See you next time. Want to go deeper into AI? Check out the MehtA Plus certification program. Details in the description. Don't procrastinate.
ME to the HTA plus, that's my zone. Leaping hurdles, breaking boundaries, never alone. Miss Paws on the block.